So I want to start saying that I was thinking of a demo for this session. And this is actually a demo. This is voice to text. It's just happening, and I didn't have to prepare for that. So it's a very cool demo. So one of the things that I want to discuss today, I want also to say that this is kind of therapeutic, because I'm going to tell a story from real life of something that I went through. And I just want to share what are the things that we have learned while doing this. But if you came, and if you are here, probably you read the agenda. So we want to answer certain questions in this presentation. And we frame it like DevOps in the era of AI application development. So let's assume that here, either you are a developer or DevOps engineer or someone who is dealing with infrastructure, or in general, a person that is building software. Or you can also be a machine learning researcher, a data scientist. It was very interesting this morning in the exercise that we're saying define a data scientist. Part of my work at GitLab is to do data science. And when I introduced myself, I just said, look, we get a bunch of data that we don't know how to understand if we just open it. We just have to make sense of that. And the reason that we call it scientist is because we have to create first some hypotheses, and we test them by using the data. That's why we had the scientist thing, because if you follow the scientific method, you have to start by outlining some questions. But in this case, we ask it to the data. That's why we are data scientists. And data engineering, we cannot do anything without data engineer, because we need that person that will pull from all different sources and give us the data so we can just use pandas and import it. So even if you are a data engineer, data scientist, or a researcher, or someone who is more willing to work or levitates more around data, so you're in the right place, because I want to talk about how when we think of people that are building software and you want to integrate AI techniques into that software that you are building, there are different ways to do this, and there is so much noise, I will say, today in the ecosystem that when you are confused where to start, my advice, we can take this from here and then we end the presentation, is we can stick to the basics and fundamentals. But there is a more complex answer. You want to build applications that use data? Sure, you just need to learn all of this. And that's it. And thank you. Thank you for your attention. Just go, you can take a picture of this. So one of the things is that this is overwhelming, and the more you start digging into this and reading, and even simple chatbots, I will say, all of these terms start to appear. And it gets more and more, can get more and more complicated when you say, okay, now I have to deploy, I have to test it, I have to measure the latency and all of these things, but there is a whole process, and all of these things, they can happen, but they should matter only to certain people. That's what I was saying. If you're an infrastructure engineer, maybe you can use your skills to support infrastructure, and you can abstract from the model and these other things. But we will go into that. My name is William, and I am a developer advocate at GitLab, and I also work in the data science team. So I do different things in the company. One of them is making sense of data, and the other one is automating or using DevOps. And this, as I said, this is therapeutic. I'm going to share from our case study of how in GitLab, that what we know a lot about is about DevSecOps and how to build software and ship it. How are we tackling this problem of how do we deliver software now that has AI embedded or is using AI in the backend? And this is a story told from the data science perspective. And a little bit of background. Back in 2017, I was a developer of what they call today agents, conversational AI, chatbot. And that's when you start seeing the main difference, is that software engineers, they are used to create code, and this code usually can remain untouched for a certain time, but data changes every day. So the main challenge is that when you have data and code, and you need somehow to treat them differently, but make them tell the same story. So you have to be able to put them all together and create something that makes sense. So back in 2017, when I was working only on this, creating chatbots for customer support and so on, we were writing the neural networks in Python from scratch. It was not that, I would say, easy to get started with, or maybe it was, I don't remember now, with TensorFlow or PyTorch. So we were doing also very basic things. We were doing text classification using a neural network to detect an intent if someone wants to buy or someone wants to to cancel one service. And one of the problems that were found there in a very small example that are still relevant today is that there are a lot of manual steps. You need to train these neural networks or these algorithms, and you do it in your computer. And there is this term of GPU poor. So if you don't have a GPU, good luck. It can take a lot of time to process and to extract patterns from the data. And because of that, also there are longer cycles to train or retrain a model and deploy it. So they said that the human brain can process 3 problems or 3 things. That's why in the storytelling you say 3 things. So there are more problems. I just wanted to choose 3 to show you how we can start tackling those 3. But if you want to dig deeper, later. So back then, I didn't know anything about DevOps. My thing was researching how to improve the scoring of some text classifier. But then I found myself doing a lot of manual steps. Then I said, there must be a better way to take all of these things and automate them, because it's just repetitive. And then enter DevOps. And one architecture that was heavily manual, that I had to do a lot of things that were error prone, it evolved to an architecture like this that later became a template to spin up new projects whenever you are working with a chatbot. So here are where the different concepts start to appear. That is that we need a version control, not only of the code, but also the data. So there is when we hear about other open source packages such as DVC or Git to keep the same, to have a snapshot of the code at a certain point in time, but also tied to the data. And then we start learning, I say we because we were more on the research side of machine learning, that we need to collaborate with other people in other countries. So you need to learn that there is something called Git, that you can have remote repositories and that people can collaborate with you if they go and read from there, and you are not sharing Jupyter notebook like it's where we usually live when we do that. And that all of these steps you can automate, and then when you automate these things, you all the time are running the same scripts, so you can put it in something called a continuous integration pipeline and run automatically all the scripts that can score the accuracy of your model. And here, this is one of the best, because we have to train a GPU, but can any of you raise your hand if you have tried to, or you have maintained a virtual machine with NVIDIA drivers? Have any of you? Okay, you are lucky, or maybe you are too innocent still, because if you have to do that, that can be time consuming when you have to deal with GPU drivers and make sure of dependency management, blah, 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 all the configuration of a GPU. So here, only on this stage of train, we were using a GPU because it's also expensive, so we didn't want to use it when it wasn't necessary. And then one of the things that's what I was saying, going back to the basics, the testing. Today, I feel that with all of these LLMs, it's more of an act of faith. Like you put some prompt, you deploy it, and let's hope for the best. And let's see how it goes. But there are tools that it cannot necessarily reduce the risk completely, but when we go back to the practices that we can learn from DevOps, there are ways to have testing of these models that they involve a human in the loop, not only the unit testing of the code or the accuracy or the evaluation of the model, but what they call in the industry the vibe testing. You give this to someone, try, play for a while, and give us your opinion before we even think of deploying this thing. And then production environments where our friends from infrastructure can help us with Kubernetes, serverless, or all of these things that they already know. One of the things is that you can think of automatic deployment or manual. So from this architecture that I just showed you, there are simple takeaways that I want to share. If you're an engineer of all the things that I mentioned before, do what you already know how to do, and think of the AI ML component as an artifact that needs some treatment that is mostly because it depends on a lot of data that keeps changing every second or every day. But if you abstract from that, think of it as it's just one more software artifact that you have to deal, like a container image that you deal with this every day. So do what you already know how to do, and if you have to learn something just to feel more informed when working with machine learning engineers or data scientists, this is like the exercise this morning. What is a model? What does it mean? Because it sounds like magic sometimes when you say, no, we are working with a model or this new model that was released. And learn what is a learning algorithm. I think that from an engineering perspective, if you learn these two things, you can start gaining the language to have conversation and live up to the philosophy of DevOps. Collaborate with the people building these things, like development and operations, but in this case, let's say the development is the machine learning researchers or data scientists. And what is a model? So I wanted to show it in as simple terms. And with this, I'm gonna play the game from this morning. Basically, when you save a model, you are saying, I am storing a bunch of layers, and those layers, they all have numbers. And these numbers were calculated by following an iterative process that is telling me if I am approximating to the real answer. And when you finish training a model, it means that it was able to find a bunch of numbers that we call weights, and then you generate a structure like this that is just telling you these numbers that you see here are the best combination that I could find to classify your dog or to classify your cat. And these numbers, the data that you take, you convert into a matrix that you multiply that matrix with those numbers against these ones, and it will give you an output, and that output will tell you this is a dog or this is a cat. So a model is basically a bunch of numbers that we call weights that you flow information through them doing matrix multiplications. This is how a model looks like. So when you open it and you see it like that, you say, okay, this is a data structure that I gave a model as a JSON. And that's what is the model. Okay, see, the magic is gone. There is no an artifact here that is super strange or is conscious or sentient, nothing. It's just a bunch of numbers that you calculate using linear algebra and optimizations. So how do you put it to the exercise of this morning? How will I define a neural network? Imagine that you have a radio or a device like this with a lot of knobs, and you have to tweak them all at the same time. And when you tweak them and you find the optimal tweak, let's say, a state of that you can listen to music in a good enough way, those numbers, if I were to take them from here and put them in integers or floats, it will be like this. So tweaking all these knobs is what it means that the algorithm is learning. So when you are passing a lot of data through it and all of these things are moving at the same time, this is the process of learning. And we say that the algorithm finishes learning when it gets to the optimal values for it to reduce some error. So if you as an engineer, you say, okay, so this is a structure with numbers that we are tweaking, that's why there is lots of experimentation. And that's what makes it so different from software engineering. You don't have to try so many things in software engineering, and it's discriminative and it's more robust. In data science, there is a range of probabilities, distributions, something that might work under these conditions, but not always is the case. Just try with the current LLMs. Two people at the same time, they can input the same prompt, and they can get totally different answers. But why? Because it is pulling from a probability distribution. It's saying these two are acceptable probabilities to deploy, to give this answer. So they cannot be repeatable, but they are within a range. They are okay. They are they have the highest likelihood. So this requires a lot of experimentation, and here is the part where I want to say, one of the values I will also say from DevOps is that when we are building software, we are also working with other people. And what are one of the best things that you can have when working with other people? You, Stefan, tell me. I know you are good with this.
Working with people.
Yeah. Okay, sorry to put you on the spot. Is having compassion when you work with other people. And I have seen it in different engineering teams, because the people experimenting, they are dealing with this mostly. So this has been a controversial thing when I have been working in DevOps, MLOps, data science, because the data scientists, we like and we love using Jupyter notebooks because it's interactive. You can try something, you see the output right away. You don't have to refactor a script and then run the script every time and go to a folder where you are storing the images. No, you just can see the output there. And it is happening more and more that there are really good notebooks that data scientists will want to put into production. And this goes against everything that software engineers know. They say, are you telling me that you want to put this weird format, this is not our script, into production? No way. But yes, we can do it, and that's why DevOps can help. We do it. We take what we call a production notebook, and we can put it into the main branch and then push it to a production environment. And why we can do that? Because we are using all the DevOps practices to ensure that if something goes wrong, we can revert the changes and nothing broke. That's one of the advantages of using DevOps. So when I say compassion, it's because I have seen that there is friction between developers and operations team. When you say, this is my code, please let's put it into production. There are ways to do it, and that's when DevOps can help us. And now, if you come from the data side or research side, this is the more of a heavy lifting. What you have to do, I will say, is keep doing what you already know. So do your research, work with your Jupyter notebook, but it would be great if you also learn developer workflows, because this is what will help you to take your developments to make them more robust and be able to share them with other people that can be working in different geographies. So what do I mean by that? Remember this architecture? The main thing that I will invest if I was starting again as a data scientist that doesn't know anything about DevOps is what is version control, how do I git commands, branching strategies, and CI/CD principles. Because there are many things that data scientists do today that is just repetitive tasks, running scripts to evaluate a model. You don't have to do that by hand. You can use a continuous iterations and continuous delivery or deployment system and automate this thing and focus more on the experimentation, the thing that you actually should be putting your time on. So here is the part where I want to share the real case study. We had a bunch of data that, again, to the data science part, if you open it, it doesn't make any sense. But this data had a lot of events of how people are using GitLab. Every time that someone is clicking, there is an event. And we wanted to learn what is the profile of someone that will end up converting to one of our paid tiers of the product. How does that journey looks like? So how can we learn from data? So this is a task for data science. And the problems that I told you that I faced back in the day, they were still there, now at the enterprise level, but they were multiplied by the number of data scientists. So now the cost of this problem was higher. We were doing this just 2 people. Now it's a team of 10, so multiply by that, and the time of data scientists not being able to be productive. And the main issue then was like, how can we better collaborate? So another tip is that we started small, and we start saying, let's use what we have, and let's build gradually. So that ended up in different things. So here, I'm just gonna make a little demo. You see that this is an application, this is a fake e-commerce store, where what is behind here is that this is what is called a semantic search engine. So if I say hackers that know Kung Fu, see if it works because it's from a Kubernetes thingy. So what I'm searching here is I'm just giving a description that this is very, very proper for especially millennials, because I like to quote a lot of movies. Today I was talking to a colleague and I was saying, have you seen the Avengers? And she didn't, but I wanted to quote one of the scenes from Avengers. So in tools like this, that right now is running the prediction, is the inference that we were talking about, this is how a product could look like. This is the end, the front end, but behind what is happening here, there is a model that is being queried, and it was sleeping. I should have done this before, because the container goes off after I don't use it for some time, but it should give me the output of the metrics. Because this is in my data set, the closest that I have to that. We will go, look, okay, it was the longest 3 seconds of my life, but you see that here when I search this, it gave me this. So this is very cool when you say, oh, remember this movie where this, and you give a description, and then you can find it. So you see that this is how a person could interact with a machine learning system. But in the back end, to create something like this, there is integration, there is an artifact that is being deployed somewhere else that is expecting an input data in certain structure, so it can take that text that I wrote and parse it and generate the prediction. And all of those things, they are done more manageable when you embrace DevOps practices. So for example, here in my GitLab instance, all of these things that you see, this is a repository that has all the code that makes possible to do semantic search. And one of the things that I want to highlight here is that imagine that you're a developer, that you were asked to, I don't know, improve the accuracy or change the model. So when I said that if you are a data scientist or someone that comes from data and you learn developer workflows, this is what I meant. So when it comes to collaboration and you say, I want to add to the code base, so you create a merge request. And when you do this, you are saying, I want to add code to this project, to this product, and I'm going to do it in a way that it will be safe. It could be the Jupyter notebook that we were talking about. So I'm just going to add a very small change just to show you the automation in action. So imagine, for whatever reason, let's say that I just changed something here, and I say these are all my changes, and then I want to push it. But you can imagine that I change a learning rate, that I change even the model, and I use a different pretrained model. And when I do this, all of those steps that I mentioned that we usually as data scientists in Jupyter Notebook or using command terminal, we used to do by hand, you can automate them. And you can see here how the image with the dependencies that you need to create your model is being automatically created, so you don't have to do Docker build, Docker file, Docker run. The testing that can be combined can be a testing of, I want to try not only the code works, but maybe that the accuracy is if accuracy, assuming is what is relevant to you, and then train the model. And this is the part where automatically what a CI/CD system is doing is that is allocating for me on my behalf a hardware that is GPU enabled. And then I just have to tell it the code that it has to run using the GPU. I don't have to deal with a virtual machine on my own, and I don't have to deal with NVIDIA drivers. So all of this automation is happening here, and this step that you see here of review, this is creating a ephemeral environment where you can do the vibe testing. So I wanted to show you, this will take some time, so I wanted to show, for example, this is another review environment that is for a chatbot. This is an open source project that you can use to train conversational agents. So as you see here, when I click on the MR on the pipeline, it created a review environment for me, where in this case, for example, I was saying that imagine this is a chatbot that you are using in a bank to transfer money. So you have the opportunity during your development workflow to create an environment that is very similar to your production environment and try the model and see how it goes and test it. You can even try adding things that make no sense and see how the model responds to that. So this is the opportunity to not only say that, because anyone that has worked a lot in software, you see this pipeline here and everything is green. Usually in software engineering, it's closer to say that if everything is green, it's because what you did was almost 100% correct. In machine learning applications or AI, all of this can be green and the chatbot can be very bad. It just was able to compile. But not necessarily if I am testing it here and if I said that I want to transfer money to my mom, and it happened actually to this chatbot. I said, it asked me, who would you like to send money to? And I say, my mom. And the chatbot replied, okay, send it to my mom. So it was funny because I said, no, my mom, not your mom. I didn't know you had a mom. So, and it worked. It worked. It was green, but only when you can do the vibe testing, you can tell about these things. The second is that this is from another project. This is a less exciting model. This is a model that is predicting churn. And you can see that here as well. These things are green. It means that it was able to train the model and make some predictions. But then you bring a trained eye, someone from data science that they understand better this, and you can assign them as reviewers. You can say, I want to assign a reviewer, and this could be someone that knows about the use case, has domain knowledge, and this person can accept or not to merge the changes in the code base based on the accuracy or these metrics of the model. So as you can see, it's bringing the developer workflows into the data science process. So what you do is that you can collaborate with other people and work in a more efficient way. There is 5 minutes, okay? There is another thing that I want to show today, which is how we are also acknowledging that there are many things changing, that they are beyond the scope of DevOps. So in GitLab, as you can see, there is one tab now that we have integrated that is called Model Experiments. And this uses an open source project that is able to track all that experimentation that we are doing on the fly. So when I click in this one, the one that I was talking, searching the metrics movie and so on, you see that an hour ago, I run an experiment where I change something, and this is telling me some metrics about the performance of the model. And now if I click in one of those experiments, I can see different things. I can see who created this model, what stage, and what are the artifacts that were generated. And you see here that I have the model that is doing the vector similarity comparison. So you can imagine that if you are a developer or another person that they say, I want to test your model, they could download this artifact and load them in their local environment, instead of trying to just run my code and rerun all these steps. So this enables to have that experimentation component that I was telling you embedded into the developer workflows. So because we only have 5 minutes, I'm gonna close. And I want to say that the experience on doing this in real life is that now we have We have a complete automated system where we are building our models, training them with GPUs, and we don't have to worry about the GPU maintenance. And this is my colleague that he's a statistician. We are now even creating a scheduled pipelines, which is an old concept in DevOps, and we are just retraining the model automatically once a week. We don't even have to trigger the pipeline now. And we configure a rule that if the accuracy goes below a certain threshold, then it needs manual intervention to see what's happening with the model, if it's drifting or what. So we don't have to worry about GPU. And lastly, I want to say as a last advice, is that with all of these things that we are seeing today about AI, LLMs, and so on, it's important to try to keep things light. Think first that not every problem needs an LLM to throw at it, so that if there is a smaller model that can do the job, go for it. And if you would stick to the fundamentals of how to build software and how to do experimentation, please do. And second, which this is very important, especially when someone has to be held accountable, is that automate as much as you can, as I was doing here, but not more than that, because you still need someone in the loop, a person that can judge if what you are doing makes sense or if the model is doing what it's supposed to do. So those are the tips that I wanted to share today. Thank you very much for your attention.